Okay, so let's finish up chapter 10, okay, 10.2. Yesterday we did 10.1, which was solving systems basically by setting up your equations, okay, and then finding a way to multiply an equation by something so we could get zeros, okay, to get rid of those other variables. All right. Well, we're going to try the same idea today, except we're going to use a matrix. Okay, the book, in this first example, they kind of have you do the same steps you would use if you were using a matrix, but they still have you write the letters. We're just going to jump right to using a matrix. Okay, we've already done this, doing it with the letters. Okay, so this is going to be the first problem we solve. Okay, I'm not going to do it yet, though. Okay, I want to explain a little bit about what a matrix is and kind of what our goal is going to be. And then we'll write this problem down again and actually solve it. All right, so if you already wrote it down, make sure you leave plenty of space to solve it. But next, I'm just going to describe a few things about matrices. Okay, first, does anybody do any kind of programming, computer programming? Yeah. Have you used arrays before? Yep, that's exactly what a matrix is. It's an array. It's basically a two-dimensional place you can put numbers. It has rows and it has columns. Okay, now on a computer, you can have arrays be as many dimensions as you want. You can have a 3D, 4D, 5D. It gets more and more complicated, but you can store data in different ways. We're only going to look at 2 dimensions. Okay? Two-dimensional structure for storing data. Okay. Also, if you're familiar with doing it on a computer, the way they have the first element in an array, they call it the 0th element. Have you done that before? Yeah. Which gets kind of confusing. So then if you had 5 things, the first one is the 0th, the second one is the first, and so on. So what we're going to do to simplify that is we're just going to have the first element in our matrix be the first one. The second element is the second one. We're not going to start with the 0th element. All right? Just kind of makes things confusing, throws everything off by 1. Okay, so the way you describe a matrix is by its dimensions, rows by columns. So an M by N matrix would have M rows, N columns. So an example might be 2 by 5. A 2 by 5 matrix would have 2 rows, 5 columns. If the number of rows and columns is the same, that's called a square matrix. Like a 2 by 2 or 3 by 3. Okay, the entries, the individual numbers that we're going to put in the matrix, those are called the elements of the matrix. And let's see. If you have a matrix, generally the way you represent it is with a capital letter. So this matrix right here, this is matrix A. And if you go on your graphing calculator, it also uses the same capital letter notation. So if you go second matrix, you can see all the matrices. I think you can use up to J, okay, for your matrices. And if you want to edit them, we go over to edit, and we can type in how many rows and columns we want it to have. Right, so if we wanted to type in a 3 by 3 matrix, we could do something like that. So if I asked you to identify the element in row 2, column 3, this is how you could use, this is the notation you could use. Lowercase a, okay, means I want an element from matrix A. Second row, third column. Okay, in this case, it's a 9. If you're doing it on a computer, you might be more used to something like whatever your matrix is, given a name. And you'd have a row and a column. That's how you'd reference an element on a computer. Okay, 2, 3. As I said, the notation is a little different because they start with the 0th one, not 1, but that's the basic idea. Okay, any questions on any of those terms? Elements, square matrix, rows, columns, stuff. All right. Okay, so the main advantage of a matrix is when we write down our calculations, we don't have to write the letters. All we're going to have to do is write numbers. In our matrix, each column is going to represent the coefficients of a particular variable. That's why when you first get your equations, you want to make sure that they're set up so that all the letters are in the same column. If the letters are not aligned in columns, we've got to rearrange things first so we get all the x's in one column, y's in a column, z's in a column. If we have time, we'll look at a 4x4 system. I'll have you solve this using a calculator. But I think by hand, I'm only going to go up to 3x3. Even 3x3 can be time consuming. 4x4 can be even more time consuming. Okay, in this matrix that we set up that has all the coefficients of the letters, that's called the coefficient matrix. So in the matrix I have on the left here, this 2 would have been in front of an x, the 4 would have been in front of a y, the 6 would have been in front of a z. And then the second equation would have been x plus 5y plus 9z, negative 8x plus 3y plus 0z. But we're going to add a column to this matrix. And the column we're going to add on is for all the numbers that are on the right-hand side of your equation, okay, all your constants. So we're going to take the coefficient matrix and we're going to add on an extra column. We're going to augment it. And that extra column is going to represent the constants on the other side of the equation. Okay, we're just going over the very, very, very basic things you can do with a matrix. In fact, we're only going to do one thing with it. We're going to use it to solve a system. If you take any math in college, there's a whole class on matrices called linear algebra. Every single problem basically is about a matrix. Okay, and tons of more stuff you can do with them. Cody, you said you've done some programming. Have you done anything with like video game design or 3D graphics?
Partially, but we just did mostly manual coding. We don't really get into the game design kind of thing because it's not part of our curriculum.
It's not part of what you guys do. Okay. If you do anything with like designing in video games or anything that has like stuff that moves in it, like 3D animation, Matrices is used for all the transformations. Like if you want to take an object in your screen and you want to turn it, you can use a matrix to do that. Right? If it's two-dimensional, the matrix is a little simpler. If it's 3D, well, it gets a little bit more complicated. But it involves trig. It's all sines and cosines in a matrix. And you can do whatever you want. You can translate things, rotate things, reflect things. Okay, all using matrices. Okay, so the goal is we're going to try to take our matrix and we're going to transform it so we have row echelon form. Okay, row echelon form is when you have ones on the main diagonal and zeros everywhere below. And if you ever take linear algebra, there's all kinds of terms you learn that are similar. There's row echelon form, reduced row echelon form. It's kind of hard to remember what everything means. But for our purpose, this is all you need to know. Okay, row echelon form. Zeros below the main diagonal, ones on it. What's above it? Anything you want. Okay, and the process to get your matrix in row echelon form has a name. It's called Gaussian elimination. So it's based on elimination, okay, what we learned yesterday. You're going to add multiples of one equation to another equation to try to get things to cancel out. Okay, Gaussian elimination is when you're doing it with a matrix and you get zeros below the main diagonal. Because we're only going to get zeros in half the matrix, okay, in the lower half, we're going to have to use substitution to finish the problem. Another way we could do it is we could get zeros in the lower half, get zeros in the upper half, and then avoid using substitution. You can do it either way. When you get zeros in the lower half and in the upper half, that's called Gauss-Jordan elimination. Okay, we're not going to be doing Gauss-Jordan elimination because we're only going to get zeros in this lower half. Okay, sometimes when you get zeros in part of a matrix like that, you might see the word lower triangular form or upper triangular form. Just more words that I think is going to confuse people. So I'm not going to write it down. Right, so on the test, if you see the direction, solve using Gaussian elimination, that's what we're about to do. Okay, so when you're doing Gaussian elimination, you're only allowed to do 3 things to your rows. Okay, one thing you can do is you can take 2 rows and swap them. If you don't like where they are in the matrix, you can take row 1 and row 2, switch them around. Okay, another thing you can do is you can multiply a row by a non-zero constant. Everything in that row. Third thing you can do, this is what we did a lot yesterday. You can add a linear combination of one row to another row. And we're going to do row 3 quite a bit. Operation 3. We'll do that quite a bit. Doing these 3 things, elementary row operations, does not affect the solution to a system of equations. Okay? It keeps everything balanced. Okay? Like way back when you started solving equations, you learned you got to make sure you keep everything balanced. If you add 3 on the left, you got to add 3 on the right. Okay? It keeps everything balanced. Now, some of these elementary row operations would mess up other things you can do with a matrix. Okay? We're just solving a system. Okay? Something else you can do with a matrix is find the determinant of it. The determinant is just a number. Okay? What can you do with it? You can do tons of things with it. But some of these operations might mess up shortcuts to finding a determinant. Okay? But we're not going to have to worry about anything fancy, anything else other than solving a system. Okay? So you're allowed to do these 3 things to solve a system. Okay, we're going to use that same notation that I started using yesterday. Any number that's circled is going to represent a row or an equation. Okay, and I think that notation will help us to kind of keep track of what's going on. Okay, so let's just start by writing our coefficient matrix, and then we're going to augment it with the constants. Okay, Brianna, what would be my first column that represents the x's?
1, -2.
2, no.
1.
1. 1, 2, 1. Okay, Darren, how about my coefficients for the y's?
-2 to 3.
Yep. -2, 3, 3. Jill, my coefficients for z?
1, -2.
-2. And then what I'm going to do here is I'm just going to put in a vertical line so I remember these are the numbers that were on the other side of the equation. -1, -3, -2. So on the left is our coefficient matrix augmented with the constants from the right side. Okay, any questions on that? Okay, so we haven't done anything yet. All we've basically done is take those numbers and store them in our matrix. Okay, now we're going to try to start doing some things. Okay, remember our goal. 1's on the main diagonal, 0's everywhere below it. You have to do this in a certain order. If you try to get 0's in a spot that you shouldn't be getting them in first, you might get a 0 there temporarily, but then when you do something else, you're going to mess up that 0. All right, I'm going to show you the order to do it in. So once you get a 0 in a spot, it never gets messed up. It's going to be there for the rest of the problem. Okay. First thing we want to do is make sure we have a 1 in the upper left. Okay. We already do. If we didn't, and another row had a 1 in it, we could swap those rows. That might be our first step. But I've already got a 1 here, so that's fine. Next thing I'm going to do is I'm going to get a 0 here. Then I'm going to get a 0 here. Let me kind of show you the whole problem. So get a 0 here, 0 here, then a 1 here, then a 0 there. That's the order we're going to go in. And there's many, many, many ways to do what we're about to do. Okay, so let's start by getting a 0 in the second row, first column. Okay, what would I have to multiply the top equation by? And then add it to the second, so that I get a 0 in that spot. Yeah?
-2.
Yeah, so we're going to do -2 times the first equation. We're going to add it to the second equation. And I'm going to write down one more thing. I'm going to write down where we're going to put the answer. That answer is going to replace what's in row 2 right now. So take the first equation, multiply by -2, add it to the second, and that's going to replace what's in the second row right now. Okay. I also want to replace what's in the third row. What could I multiply the first equation by? Add it to the third to make a 0 in the first column, third row. Yeah. Yeah. Take -1 times the first equation, add it to the third equation, and we're going to put the answer, and that's going to be my new third row. Okay, so we're going to do all of that in one step. Notice we're not replacing row 1. We're only going to replace row 2, we're going to replace row 3. Copy down row 1. Row 1 will never change. Okay. In any problem we ever do. Okay. It's always going to stay the same. Unless you decided as your first step to swap something and get a new row 1. But once you start doing the problem and you've decided what you want row 1 to be, it's going to stay the same. That would not be true if we did Gauss-Jordan elimination. Okay. But we're not doing that. Right, so now we're going to go through. We're going to take -2 times everything in row 1, add it to row 2. Okay. What's -2 times 1? -2 plus 2? 0. Okay. Next one. What's -2 times -2? 4 plus 3? 7. Okay. -2 times 1? -2. -4. And lastly, -2 times -1 is +2. Take away 3, -1. Okay, now do the next calculation. -1 times everything in the first row, added to the third row. Okay, Victoria, -1 times 1?
-1.
Plus 1? 0. Okay, next one. -1 times -2 gives me +2 plus 3 is 5. Next one, Casey, what's -1 times 1? -2? And -3. Okay, Andy, last one. -1 times -1? -2? -1. Okay, so that's our first step. We have 0's in those spots. You're never going to go back and use row 1 for anything else in this problem. If you do, you're going to mess up these 0's. We're going to add combinations of row 2 and 3 together now. But no matter what I do with rows 2 and 3, I can't mess up these 0's. They're always going to stay 0. All right, so there's two ways we could get a 1 in that spot. One thing you could do is multiply everything by 1/7. That'll give you 0, 1, -4/7, -1/7. The only problem with that is we're going to have to deal with denominators that are 7. We can kind of put off dealing with fractions for a little bit. We're going to have to eventually. But if I can deal with fractions that maybe only have denominators of like a 2, that's a lot easier than a 7. So did anyone see something I could multiply row 3 by and then add it to row 2? So it's going to make this number smaller. It's not going to be a 1, but we can make it smaller. Yeah?
Can you multiply row 1 by 3?
Not row 1, right? Row 1's out of this for the rest of the problem. Okay? Only because if you multiply it by 3 and add it to anything else, those zeros are going to go away. Okay, so row 1's gone. What could I do with row 3? Multiply it by something and add it to row 2. It's not going to make a 1 here. If it did, if this was a 6, then I could easily make a 1 here. Darren? Yeah, let's multiply the third row by -1, add it to row 2, and that's going to replace what's in row 2. So all we're going to do is replace row 2. Keep row 1. Keep row 3. Now we're going to replace row 2. Do -1 times everything and add it to row 2. Okay. -1 times 0 is 0. 0 plus 0, 0. See, we didn't mess up the 0. Okay. -1 times 5 is -5. -5 plus 7, 2. Okay. 2 is a lot easier to work with than 7. That's why we did that. -1 times -3, that's going to give me +3. Take away 4, -1. Last one. -1 times -1, +1, take away 1, 0. The fact that we got a 0 here, that's fine. Are we trying to get a 0 there, though? No, just it's the way it happened. Okay, so now I think we've avoided working with fractions as long as we can. We've got to get a 1 in this spot. What could I multiply row 2 by to get a 1 in that spot? Yep, 1/2. At least we're only multiplying by 1/2 and not 1/7. 1/2, a little easier to work with. So we're going to take half of row 2, and that's going to replace what's in row 2. So we're spending a lot of time copying down the same thing, and not much is changing. Okay, but that's kind of the way this goes. Okay, take half of everything in row 2. 0, 1, -1/2, 0. Not a bad fraction. Okay. And because we got a 0 in this last spot, we don't even have a fraction here. So it actually, that step we just did previously worked out pretty nice. Okay. Next step, we want to get a 0 right here. Okay. Don't go back and use row 1. That's going to mess up these zeros. Can only use rows 2 and 3 now. Anyone tell me how we could get a 0 where the 5 is? Darren?
Multiply the second one by -5.
Okay. Take -5 times the second row. Yep. And do what with it?
To the third.
Add it to the third row. And that's going to replace what's in the third row right now. Okay. So again, rows 1 and 2 don't change. Now let's go through and do what Darren just said. Okay, what's -5 times 0? Jill?
0.
Plus 0? 0. Stays the same. Okay, Alex, -5 times 1
I think it's bad.
plus 5,
Yeah.
0. Okay, -5 times -1/2. Cody, what's -5 times -1/2? If you want to use a decimal, you could use that too.
2.5.
Yeah, you could write it as 2.5. And what's 2.5 take away 3? -1/2. And then the last one, -5 times 0, that's 0, take away 1 is 1. Okay, any questions on what we just did in that step? Okay, now my last step. I want a 1 right there. And then I'll have all 1s on the main diagonal and 0s below. How would I get a 1 where the -1/2 is? And this is just going to be an operation that's only going to affect the third row. You're not going to use 1 or 2. Can't go using row 2 anymore. If we did, we'd mess up that 0 now. So rows 1 and 2 are done with this problem.
Multiply by -2.
Yeah, just multiply everything by -2 in the third row. And that's our last step. And then we got to figure out what x, y, and z are. Okay, multiply everything by -2. We're going to get 0, 0, 1, 2. Okay, look at this last row. If you were to change this back into an equation, okay, trying to remember what each of these numbers meant, what would be the equation for this last row? Yep.
Z equals 2.
Yeah, z equals 2. 0x plus 0y plus 1z equals 2. So when you put it in row echelon form, you should have z right away. Okay. Now we're going to go back to the second equation. Doesn't have the x in it. All it's got is y and z. But we know z. So now we can find y. So the second equation says y minus 1/2 z equals 0. So we get y equals 1. Now we're going to take both of those numbers and plug them all the way back into the first row, which says x minus 2y plus 1z, okay, z is 2, equals -1. So we get x equals -1. Okay, if you wanted to write this as an ordered triple, it'd be -1, comma 1, comma 2. You could write the answer that way. Okay, any questions on what we just did? It might feel kind of awkward at first to go through it, but once you get familiar with matrices and elementary row operations, you really can start to do these things pretty fast. What usually trips you up is when you make an addition error, or you multiply a negative and a negative and you write negative. That's what messes you up. All right, let's try this one. Now you don't have to write the equations that you see them in that order in the matrix. If you want to swap rows, you can. Let's look at it and see whether or not swapping a row would help us. But let's start by putting them in the order they're in. Okay. Kobe, what would be my coefficients for x?
Me?
Yeah.
1, 2, and 1.
Yep. Good. 1, 2, 1. Okay, Emily, how about for y?
0 to 6.
Yep, good. 0, 2, 6. And Colby, how about for z?
1, 4, 8.
Yep, so things aren't lined up here. Okay, you got the z's over the y's in that first equation, so you got to make sure we line everything up in the matrix. Put that 0 in for y. So you got 1, 4, 8. Okay, augment that with the constants from the other side. Okay, now in the last class, somebody had a suggestion they thought would be helpful. I want to see if we come up with that same suggestion and talk about it. Anybody have any thoughts before we even start? What you might want to do here? You'd think it might save you some work, but I'm going to explain something in a second. Yep?
Switch the first and third row.
Yeah, if you switch the first and the third row, you'd be getting a 0 in this spot, which is one of our goals ultimately. But you can't get a 0 in this spot till you already have a 0 in that spot. Because what's going to happen is if you put the first row down here, you're going to get a 0 here. And then when you try to get a 0 here, you're going to mess up that 0. Anyone see that? You're going to mess up that other 0. All right. So it's a good thought to switch the first and the third row. It's just this 0 won't stay a 0. It's going to change after the first step. Okay. So our goal, let's get a 0 here and a 0 here. Whatever happens to these two numbers, well, who cares right now? Just get zeros in the two spots I circled. All right. Yeah, what can I multiply the first equation by and then add it to the second to make that a 0?
-2.
Yeah, we're going to multiply everything here by -2 and add it to the second row. So -2 times the first, added to the second. That's going to become my new second row. Yeah?
Why would you multiply it to the first?
Because this row already has a 1 in it, right?
Yeah.
So then we're going to multiply that by -2, add it to the second. That's going to become a 0.
Oh, okay, so the one stays the same.
Yeah, we're not going to store anything in row 1. Yep, row 1's not going to change. We're going to put our answer in row 2. So this part is just the calculation we're going to do. This part is where we're going to put the answer. Okay, how about for the last one? What could we multiply row 1 by and then add it to row 3 to make a 0 here? Yep.
-1.
So -1 times the first row, add it to the third row, and replace the third row. All right, so let's go through and do that. The fact that there's a 0 in the second spot in row 1, that's going to make some of the arithmetic easier. But that's about it. So -2 times the first row added to the second. So 1 times -2 is -2 plus 2, 0. Okay, Augustine, what's 0 times -2?
0,
Plus 2?
2,
2. -2 times 1 is -2 plus 4, 2. -2 times 4 is -8 plus 10, 2. Okay, now let's do our last row. Emily, what's -1 times 1? Plus 1? 0. Okay, Brianna, what's -1 times 0? Plus 6? 6. -1 times 1, that's -1 plus 8, 7. And lastly, -1 times 4, -4 plus 4, 0. Okay. Okay, now to get a 1 in this spot, it's actually not that bad. We're not gonna have to deal with any fractions in our matrix. Okay? What could you multiply everything in row 2 by to make a 1 in row 2, column 2? Darren? Yeah, so let's just take half of row 2. And we're going to make that the new row 2. Rows 1 and 3, copy them over. All right, so we've got 1, 0, 1, 4, 0, 1, 1, 1, and then 0, 6, 7, 0. You don't have to tell me what to do. Who can just tell me my goal? What's my next step? You don't have to tell me how to do it though. I want to get what where?
To make 6 a 0.
I want to make 6 a 0. Okay. Maybe if you start looking ahead a little bit, something else will turn into a 1 at the same time. Let's see what happens. Okay, so we're going to take -6 times the second row and then add it to the third. And that's going to replace what's in row 3. Okay, so the arrow is just where you're putting your answer. All right, so we get 1, 0, 1, 4. That first row, again, I can't say that enough. Don't touch it. People try to start using the first row again, and then they mess up the other zeros, and they're like, I'm stuck in this circle. I can't get zeros. It's because you're not doing it in the right order. Okay, so we got our zeros, got our 1, we'll get our 0, and then our 1. All right, second row stays the same. Third row, multiply everything by -6 and add it to the third. So we get 0 times -6 plus 0. 1 times -6 is -6 plus 6. And 1 times -6 is -6 plus 7 is 1. That's great. It doesn't always happen, but it did here. Okay, -6 times 1 is -6 plus 0, -6. So now we already know z. Okay, what's z? Yeah?
-6.
Yeah. 0x plus 0y plus 1z equals -6. Z equals -6. Okay, now go back up to your second equation. Okay, because we only have zeros below the main diagonal, we've got to do this substitution. We could actually get zeros above the main diagonal very easily in this problem, because we already have a 0 in this spot. All we'd have to do is take -1 times the third equation, add it to the second. That would give me a 0 here. And then take -1 times the third equation and add it to the first. And it wouldn't mess up these other zeros because you've got zeros in these 2 spots. So it's not going to change any of the numbers above it. And then you'd have zeros, zeros, and 1s, and you could read off each answer. All 3 answers would be right in the augmented matrix. Okay. But I said we'll go back and we'll do the substitution. So now we have y plus z equals 1. So that's y minus 6 equals 1. Y equals 7. And now we're going to go back and substitute one more time. Okay, last equation is x plus z equals 4. I suggest always substituting the way I did. Get z, then y, then x. Although this time you could have gone out of order because you don't need y to get x. You don't need y. All right, so x plus z equals 4. Any questions on that one? Okay, if you have time and you want to try it another way, you might want to try that step I said about multiplying row 3 by -1, adding it to the second and to the first row. You'll get the same thing we just got. Okay, one of kind of like a big thing in computer programming is how quickly you can solve a system. And basically, we could figure out how many operations do we have to do. The less we have to do, the faster we could solve it on a computer. So for a 3 by 3, we could count up how many steps we really just had to do. Right? And we could try to find a pattern. So if you have a 3 by 3 matrix, how many steps did it take? Right? So we had to multiply here, then we had to add, and we had to store a new row. Okay, so it's a few different operations we had to do. Okay, I forget what it comes out to, but I think it might be close to n squared. So if you have a 3 by 3 system, you have 3 squared steps, roughly, about 9 steps. Okay? If you have a 10 by 10 system, it would be about 100 steps. Okay? And the question is there a more efficient algorithm than what we're doing? Is there a better way to do it than getting these zeros and ones? And there's all sorts of fancy ways you can try to cut out some steps. Okay, there are shortcuts. Okay, but I'm showing you something that's very basic. We're not going to go and do real big problems. We're gonna skip over that one. Okay, so it's another problem. Just make sure you fill in z as 0 in the first equation. Right, so all the problems we've worked with matrices come out with nice answers. Okay, single solution for x, y, and z. It's possible when you solve it, you could end up with a row that's something like 0x, 0y, 0z, and a 5 on the other side. Okay, that could happen. What do you think this would mean? 0x plus 0y plus 0z equals 5. Yeah. Yeah, this would be a no solution problem. Right? If you ever ended up with zeros in the coefficient matrix and a number in the augmented part, there's no solution. You could also end up with something like this, an entire row of zeros. Well, if that happens, you're basically getting 0x plus 0y plus 0z equals 0. 0 equals 0. What would this mean? Well, Alex, what do you think?
Infinite?
Yeah, that would be infinitely many solutions. Okay? The only way this would happen is if you had two equations that were repeats of each other. Okay? So if you had a matrix, just do something simple. 2x plus 3y. Just put in the numbers, 2 and 3. So 2x plus 3y equals 5. And negative 4x minus 6y equals negative 10. This second row is a multiple of the first row. So if I took negative 2 times, or even actually just 2 times the first row and added it to the second, I'd have 4, 6, 10, negative 4, negative 6, negative 10. I'd get a row of zeros if I did what I just said. Okay, so that's infinitely many solutions, or in this case, they're the same line if you graph them. Okay, questions on that? All right, so last thing I want to look at is how you can use your calculator. Okay, and if we have time, we'll try to solve this 4x4 system. Although, since Mr. Babb made it up, it's probably going to have decimal answers. So it's probably not going to be nice. But the calculator doesn't care how the answers come out. All right. How would you solve that equation? (3x equals 12). Yeah?
Divide both sides by 3.
Okay. Divide both sides by 3. Okay, that works. That's fine. Let's look at it again. What's another way to solve that equation? I want you to pretend the word divide has been removed from your vocabulary. You're not allowed to say that word anymore. Yep.
Multiply by fraction, 1/3.
Mm-hmm. You can multiply each side by 1/3. you get x equals 4. And this is the way that I want to focus on. Okay, because division is not something you can do with matrices. It's not an operation that exists. It's not defined. Okay, so division doesn't exist. But we can kind of get around that idea by thinking of it this way. What's 1/3 the same as? What's another way to write that? I want you to think exponents. Not 0.3 repeating. I don't want that. But how do you write 1/3 using 3 as your base and an exponent? Yep.
3 negative 1 exponent.
Yes. Okay. That's the idea that's going to be important here. Okay. So if we wanted to solve this equation, one way to do it is to multiply each side by 3 to the negative 1. 3 to the negative 1 times 3 cancels out. If you're confused why, another way to think of it, you multiply things with the same base, you add the exponents. Negative 1 plus 1 is 0. 3 to the 0 cancels out. Okay, this idea is what's going to be important. All right, so say we had x, and it was multiplied by not a number, by a matrix. Okay. And on the other side, we had another matrix. If I wanted to, and I'll even put it in brackets so you remember it's a matrix. How could we get A on the other side and get x by itself? Could we multiply each side by?
By a to the negative first.
Right, by a to the negative first. Now, be very careful about how you write this down. Matrix multiplication is not commutative, meaning you cannot switch the order. With regular numbers you can. 2 times 3, 3 times 2, same thing. But this, which is what you should write, okay, a to the negative 1 has to come before to the left. So this is not equal to this. We're not going to get into matrices and explain that why. In fact, it might even be impossible. You might be able to do what's on the left, but it's impossible to do what's on the right. You can only multiply matrices together if they meet certain conditions. Okay? The number of rows in one of the matrices has to match the number of columns in the other one. Okay? We're not, again, I don't want to spend too much time getting into that, but that's the quick idea with matrix multiplication. The number of rows in one of them has to match the number of columns in the other. Okay? If they don't match, you can't multiply them. It's undefined. All right, so we multiplied each side by a to the negative 1, which is going to cancel out that, and get our variable by itself. This is the basic idea of how you could type it in on your calculator. This is the inverse of matrix A. That's how you pronounce that, inverse of matrix A. How do you find an inverse? It's not that hard. You guys basically could do it. You use elementary row operations, and you just have to get zeros and ones in the right spot. And you could find the inverse very easily by hand. Tedious, but easy. Okay. We're not going to teach you how to do that by hand. What matrix A represents is your coefficient matrix. So you need the inverse of your coefficient matrix times the matrix that represents the constants on the other side. So this is the augmented part of matrix. It represents the constants. So what I'm going to do, go back to a problem we just did. I'm going to type in my coefficient matrix on the calculator. Type in the augmented part, this separate row by itself, and see if we get the same answer. Okay, so first thing we got to do is just get all the numbers in the calculator. Then we'll come back to that. All right, so So let's find a problem. Okay, so example 2. Okay, we already have the answers. Okay, let's type this in. Okay, so on your calculator, press second matrix. Then when you press second matrix, you're going to have 3 things: names, math, and edit. Okay. You want to go over to edit. Once you're on edit, hit enter. Okay, first thing it's going to ask is how many rows do you want? How many columns do you want? So press 3. Press 3. Hit enter. And it should give you a 3x3 matrix. Now we're going to type in all the coefficients. Okay. So you just press a number, and you hit enter. Okay. The way this works is it goes across if you hit enter. All right, so you type in 101. Then you're going to type 2, 2, 4. And in your last row, 1, 6, 8. Okay, don't worry about this other column. This is going to be matrix B. It's going to be separate. Okay, any questions on getting the coefficient matrix in the calculator? Okay, once you have that, it's automatically saved as you type it. Press second. Press matrix. And now what we're going to do is go down and edit matrix B. You don't have to use A and B. I'm just using the same letters I used. Okay. I think it goes up through J or so. Okay, so go to edit on matrix B. This time you want 3 rows, 1 column. 3 rows, 1 column. Type in 4, 10, 4. Okay, everyone have that typed in. Okay, now we're going to go back and use our formula. Okay, where do we have it? We need the inverse of matrix A times matrix B. So you're going to press math. I'm sorry, not math. Second, the button right below math, matrix. Don't go to edit this time, just go to names. So we're going to take matrix A, take the inverse of it, and then multiply by matrix B. Second, matrix B. And when we hit enter, we're going to get the 3 answers, X, Y, and Z, in that order. Let's just check. So X is 10, Y is 7, Z is -6. Right, so this gives us a quick way to basically solve any system as fast as you can type it in. Now on the test, if all I see are your 3 answers and there's no work for how you got them, I'm going to mark it wrong. So I showed you this. I'm giving you a way you can check your answer, but I'm warning you, if you just do this and I don't see any work, it's not going to be right. Okay. So let's try the 4x4 system. Okay. If you were to try to do this with row echelon form in Gauss elimination, this would take a while. First thing I'd do is I'd swap the first 2 rows, so I had a 1 in the upper right. Then I'd have to get zeros in those spots. Then I'd have to get a 1. Then a 0, then a 0, then another 1, then another 0, then another 1. Look at all the 1s and 0s I'd have to get. Would definitely take a while. So let's just try typing it in and see what we get. Right, so I'm going to go second matrix. This time I need a 4x4. Okay, if you can't read it, I'll just read them off to you. It's 2, 3, 4, -6. Next row is 1, 1, -1, -1. Now, I didn't check and see if this has no solution. So if this is a problem with no solution, we'll notice that pretty quick. The graphing calculator doesn't deal with multiple solutions and no solutions very well. Okay, not this method. Let's see. So 24, negative 12, 4. Negative 3. And the last row is 8, 8, negative 4, negative 3. Okay, so there's our coefficient matrix. Back to matrix. What's going to be the dimensions of my augmented matrix part? Yeah, it's 4 by 1. Okay, it's going to keep everything I already had in it. Is any of that? Negative 2, 4, 0, 0. Okay, so we got that typed in. You can just pull up the last calculation we did. All right, so it is solvable. So you just have to go back and look at the order of your columns to figure out which answer was which. Our first column was W, so W is the first number, then X, then Y, then Z. And that's it. Any questions on that? So if I give you a question tomorrow, like it might be a bonus question, and it has, I'd give you something that you couldn't do by hand in a reasonable amount of time. Maybe even 6 equations and 6 variables. You could type it in probably 60 seconds. But to solve it by hand, yeah, you wouldn't have enough time in the class to do it. All right? But if you know how to do it on the calculator, it could be an easy bonus question. Okay. All right, any questions on matrices? All right, so the homework, don't forget back in the book, we're not in the packet anymore. Be page 553, 1 to 6, 17, 18, 21, 24, 31, and 32. So we'll go over that before our test, and then we'll have our test on tomorrow.